Hello. So we have been working a lot on LispBM, Joel and me, the past weeks or months. And the 6.05 release will have a lot of those updates, and you can already try them out in the beta for now. And I will talk about these changes now. There are also a lot of changes on that are specific to the ESP32, such as a display driver and some other things, but I will not talk about them in this video. And I will start with the simple updates, and the first one is that you can use curly brackets for prog_n, and I will show that quickly. So if you make a loop while true, and you want to do more than one thing, then remember that you have to do a, let's see, then you have to make a prog_n to do that, and also close it, obviously. Cannot type today, it seems. And we can also indent that, and then we can do, for example, print test, and we can sleep for 1 second. And then if you stream this, then you can see that it should be working. Now type prog_n, should have been print stream. Okay, so another way to do this now, I will leave this one here and show the curly bracket version of this. So you can do loop while t, and then instead of prog_n we open a curly bracket and press enter. And now it does the same thing as Qt Creators, and we press enter here, it will auto indent the next line for you. Also now when you make a parenthesis, it will make the magic one for you. And then you can do the same thing here now. Print test add sleep 1. And now when I run this code, you can see now it's a lowercase letter, but this one does the same thing, so you can replace prog_n with the curly braces. And yeah, that makes it look a bit less cluttered, and I think I generally like that syntax. It's a very simple update in the parser that just replaces this one with a parenthesis and a prog_n. Okay, so the next one in the list is var. Now, remember that you have define or def a5, and then make a global variable that is 5. And now if I stream this one, you can see that we have it here. And you could also print it here in this loop, for example. Print a. Now I'm doing Control W to stream. But if you want to make a function, for example, defun calculate something that takes an argument a, and now we can use a curly bracket here as well, and then we want to return, say, plus a2, then well, that obviously works, but suppose we want to make a variable here to store something in between, and you can of course make a global one in here. So you could do, for example, def b times a4, and then you can do plus a b and return that. And now if we run this code and we do print cal, what to call it, cal4, and run it, then it will be 20. But now I see that they have b in here as well, and that is a global one now. And if you have another function that runs in a different thread and uses the same name, then that will not work. Likewise, if you would nest this one and try to shadow this name, that doesn't work. So if you wanted to do this before, you have to make a local environment with let, but now instead of this you can use var as variable. And if I run this code now, you see that it still prints the 20, but we don't have this one as global variable, so this one will be a local variable for this function. And you can also make another one later on. The function will always return the latest expression, so you can do, for example, var c, and that will be this expression, and then you can return c plus c1, of course. And that should work the same. And you can also, for example, we could make, yeah, I will not show shadowing, but this is just a convenient way to make local variables and functions like this. Next, setQ. So before you had the setVar function, so you could do, if you want to update C, for example, here, so then you can use set or setVar. And if you use set and you want to use C, then you have to quote C, because otherwise it will evaluate the first argument as a regular function. So if you want to use a binding or something local, you have to quote it. And then we can set it to 4 and then return it. And this function, it should print 5 here now. So let's try that. But if you do it without the quoting, it will not work, because now it tries to evaluate C and use whatever it evaluates to, and it's, well, not gonna evaluate anything, so that's not gonna work. But now we have set Q, and the Q indicates that it will quote it for you. So set Q, you give it just a variable name. So there's also a small thing that lets you do this as not a quote, and the reason is that it's yellow now in this color is that this is actually a special form, because it will not evaluate the first argument, where set is not a special form, it will evaluate the first argument. And in some cases you will need set, because maybe you have a function that will return some binding that you want to set to something. So it's useful to have both, but in vast majority of cases you're probably going to use setQ. And then with those updates, if we have a bit larger example here, for example, is this CRC function. So here we have a CRC table, and here's the old way. Here we use let the local environment to make a few things, and then we make a loop here, and then we set var here, and we have prog n here as well. Now if you use the new way to do the things, then you don't have to have the prog n, you can just use a curly bracket, and then you can make a var CRC here. And then you can loop, and then you can use vars and set q in here. And then that will do the same thing, but I think most people have programmed in C and Java and Python and things like that will probably be more familiar with this syntax. And also, if you don't have to use let, one advantage you get is that if you use let to make a local environment, you have to put every new variable or binding at the top. And sometimes if you have a bit more code, you want to put them exactly at the place where you're going to use it, then that makes it a bit more clear what you're doing, and it's a bit easy to do that when you have the var keyword. Okay, so that is var. Defunret, that's also a quite simple one. So it's actually the same thing as defun, and you can use it interchangeably. Let's see to do this right now. Yeah, and the only difference is that you can use return this one. So this one actually uses call CC internally. And then you can do, for example, if a, or if less than a3, then we can do C return. What should we return? 1. And if it's not, and otherwise we continue this function and we return 5. We can also use return down here. Let's do that, actually, it doesn't really matter. Return 5, and then stream this one. Let's see what I did wrong here. I think I removed whatever this one was using, and I think I didn't give the function a name, so let's try that again. And then we can do test 1. I'm using it down in REPL now, so when I stream this, then I will have access to the function in REPL here. So if we do test 1, we return 5. But if we give it more than 3, so 4, then we'll return 1. So it means that it will exit the control flow here and not go down here. And the reason that we have a separate function, defunret, even though it works in an equivalent way to defun, is that this one has a bit of overhead. So if you want to call it often, this one will be slightly slower and take a bit more memory. I'm considering just having defun and have the return option in both, but I think for now define ret is, well, a convenient way to do that. And have the option of not having a return and having a bit faster, lighter function. Okay, so what is next? Flash memory, and this is a big one. This one took a lot of effort from Joel to make a lot of new internal changes to LBM, and I also had to spend a lot of work on figuring out how to use the flash memory. So this is the memory layout of LispBM. So you can see that we have the heap memory and we have LBM memory, and you can see how much you have used them here in VESC tool. Now, the LBM heap is actually what the garbage collector runs on, and all the code and everything that you run will end up here, and it will execute the code in here. And LBM memory is kind of like the regular malloc and delete kind of memory that they have in most programming languages, and it will use it in some occasions. For example, when you make arrays such as strings, it will end up here. All your symbol names, the names you give symbols, will also end up here, and strings. And I think also if you make, for example, double precision numbers, then you will have a cell in the heap that allocates an LBM memory cell. And yeah, so when you type the code here, when you write the program here, let's one that is not empty, such as this one, then that text will end up in the flash memory on the STM32 or in the SP32. And then when you start running the program, it will run the parser, a tokenizer in the parser, and it will read this program. And as it reads it, it will write the lists that it creates in LBM heap. All the functions and everything, they're just lists of symbols and numbers and things like that. And when you finished reading this one, it will start to execute the code here. And you see that you don't have a lot of memory in the first place, so all of your code has to fit here, all of your functions and everything. And also, if you fill this memory with code, then it will have less and less space left over for operations, things like that, that will use the heap. So this is a quite significant limitation on how much code you can store in one of those scripts. And I thought that most people will use smaller programs and it doesn't really matter so much, and that has been the case for a lot of the users, but there are some people who have been writing quite large programs that have started to approach 1,000 lines of code. So, and when they grow that much, then they don't really fit in the heap anymore. And until now there hasn't really been an easy way to do something about that. You simply have to make your program smaller, or you can do things like you can load imports, and you can load in a new import and use that, and then load another one. For example, if you have a display user interface, and then you can load and parse a new program for every page, for example, and overwrite the heap. And overwriting heap is as simple as just redefining something, and then all of the old cells that were in that global define will just be garbage collected later. And I mean, that works, but if you need more, then you would like to have utilized the flash here as heap. And you can do that now, and I will show how to do that. Yeah, also if you import files, for example, when you write import in VESC tool, it will put the file in the flash memory and then make a heap cell that points to that file, and that file will be an array. So otherwise arrays are here, but now the array will be in flash memory. So now what you can do is that let's go to this example again. So if we do stream on this one, now the heap says 0 because we haven't run the garbage collector yet, and when we run the garbage collector, it will the first time know how much heap we actually need for this program, and this turns out to be 6%. Which isn't so much, but it's still not nothing. And what you can do now is you can do move to flash. Let's see, move to flash, and then this one can take more than one argument, so we could just do these two, B and B2, and actually run garbage collection here and do stream. And now I see that the heap went down to 0 because now all of the code is in flash. there will still be a tiny bit of heap used for, I think, the binding list. The global environment is in the heap. So we do env, then we can see that. Well, we still have those functions, but we don't on the heap. And if you type info, then you can see that now the flash memory, we have used 276 cells and we have 32,000 cells in total free, which is way more than the heap that we have otherwise, which has like 2,500 cells. And yeah, so that is one way to do that. Another way to move it to flash memory is to you can use a reader macro for that. So you can, yeah, I forgot to mention, you can also move this one to flash memory. So let's see if we go back here, and now you see that we had 24% LBM memory. And if we move the CRC table into flash as well, then and stream, then this one is done at 21%. The memory will update it right away, but the heap you have to go to the first garbage collection because actually it will grow all the time. And really, when you do garbage collection, that's the point, when you know how much you actually have left, because the thing that is left after a garbage collection are things that you couldn't garbage collect, which will be needed in your current program then. Okay, so the other way to do this is to use a macro called @const start. So you put this one in the beginning where you want everything to end up in the flash memory, and then you put @const end at end, and then you have to use upload. If you stream now, these will not work. I think I will go into why that is in a bit, but if you use upload, then these will end up in flash as well. And then you might wonder, well, if I'm writing to flash every time I start a program, will that not wear out the flash? And the way it works is that it will actually, when you upload, it will erase all of the flash, or when you do erase, and then when you run the program, and then it will write this program to flash, so it will end up somewhere here in the beginning. And when you know how much you have left over and you run the program, then it will start, as you move things to flash, it will start, instead of putting them on a heap, it will start putting them behind there on the other flash that is erased. But when it does that, it will first check if the thing that you put there already is there, and if it is, then it will not write to the flash. And that is why when you have uploaded the program and you do reboot the processor, and it will start that program again and tries to write everything to flash, it will see that it's already there, because it will hopefully have exactly the same behavior the next time, and then it doesn't actually have to write to flash. So every time you do upload, you erase it, and then when the program runs, it will write it. Now, if you use move to flash actually works when let's see, go back. Move to flash actually works when you do stream as well. But now, when I did move to flash, you see that we got a fatal error on move to flash. It didn't work, and we couldn't write to flash, and that is because we did stream and we had done upload before, and that means there already is something on flash, namely this text here, and then it will try to write to it, and after the write, it will check, did it succeed in writing, and if it didn't, then it will give this error. The flash actually works in the way that when you erase everything, all the flash bits will be 1, and then you can always write anywhere you want, but you can only turn bits from 1 to 0s, but you can not turn them from 0s to 1s. And I can actually make a small demonstration, so I will do erase, and then now we have an empty flash, and then we can do def a, let's make it a list 1, 2, 3. And then if we do A, it still works, and we can do move to flash, and it still works. And then if we do info now, you can see that we have used 6 cells on the flash for this list. And then if we continue here now, we can actually redefine it. We can do it 1, 2, 3, 4, and then we can move it to flash. and that will still work. And the reason that still worked is that now we just added new cells after this, and this also shows that you shouldn't have a program that keeps moving things there, because it will just, every time you use move to flash, you will just use more flash and move the pointer where you write forwards until you don't have any flash left. But now if you do reset, which means we don't clear the flash, then if we do info, we see that we have used flash cells 0, and then we do define A 1, 2, 3, 4 and move to flash with A. And that happened to work. Probably a coincidence. Let's try that again, but make it 1, 2, 3, 5 this time and move to flash. Oh, I think it worked, but it didn't work. Yeah, I have to look into that, but anyway, when move things to flash, then it will, and there already is something there, it will not succeed, but that is generally only an issue if you use stream and didn't use erase before. When you use upload, it will more or less always work. Let's have a look at another example. So this is the, what is it called, the NAU7805 or 2, I think, driver. This ADC chip for load cells. And this program is a bit larger, so if you do stream on this one and do a garbage collection, then you can see this one uses 36% of the heap and a bit of memory, and it will not go down. So if you use this driver as it is, it will always use this amount of space. And if you have a few of those and a lot of your own code, it will, well, the space will disappear quite fast. And now if we do the same thing, but we do the const thing, const start. Now I can also show another mistake. If we do const end here, this will probably not work if you do upload. And that is because now we also created 2 buffers here that we're going to use for the I2C communication or for ADC reading. And since we are in a const block, it will move those buffers to flash as soon as you create them. And then we do buff clear. And the thing that happens when you do buff clear is that it will try to write it to these buffers, which are in flash now, and that will not succeed. And that is why we get this error here. Can probably make a better error message. But the thing that we have to do is that we have to move this one const end up here, and let's see, we can actually move this function, or we can even have another one of this. We can have another const start and const end here, and this will end up in RAM, in LispBM memory, and this will end up in flash then. So do upload, and this worked, and now we do garbage collection, and you see that we are down at 2% heap now, and the same amount of memory because, well, we still need those buffers in RAM. And that will allow you to fit vastly more code because you have so much more flash memory. And now if you look at the memory diagrams on the STM32, you can see that you have all of those 128K available. And the ESP32 actually has 0.5 megabyte of flash, so this one has a lot of memory, so you can make really big programs like this now. Also a note about the ESP32, so you can see that the heap has 8 1632K and memory 1632K. And what this means is that on the ESP I made it so that if you use Wi-Fi and Bluetooth, which will use a lot of RAM, you only get at 8K in the heap and 16K in the memory. If you use one of them, so Wi-Fi or Bluetooth, but not both, then it will give you 16K heap and I think 32K memory, or 1616. And if you use none of them, if you don't use Wi-Fi or Bluetooth, you get 32K and 32K. But the same thing applies here, that you can move things to flash, and that way you can make very large programs. Or, well, everything is relative, but as large as you, well, probably would expect on something that runs on a motor controller. A couple of thousand lines of code easily. Okay, so that was flash memory. Now incremental reader. this is something that is related to the flash memory. It's not super important to understand. It's more of a technical detail, but it's really, if you go back to this one, for example, before, when you have a program like this, you would first do the reader, and then the reader has to finish traversing everything and put everything in an array in the heap, and then it will start to evaluate it if you do upload. And if you have a large program, then it doesn't really help if you move it to flash, if it will not fit on the heap when you do the reader in the first pass. So now what the reader does, the incremental reader, means that as soon as it reads a finished expression, like this one and this one, or this one, it will evaluate the expression it just read after it. And that means when it has evaluated that expression, it can garbage collect whatever it read in after that. So if you have constart here, it will read-evaluate, and read-evaluate, and then will be moved from the heap to flash and removed from the heap every time you evaluate it. So you can just keep going and don't put so much burden on the heap. If you do stream, it will not use the incremental reader. So stream is really, well, more for experimenting if you want to upload things fast. But you couldn't really reuse constant stream reliably anyway. But yeah, that's the incremental reader. So it also is one of the pieces that you need to make a lot larger programs if you have a lot of code in one file. And then last thing is that we removed some array types. So this is something that breaks some backwards compatibility. And what I mean is, before you could do def a, and then you can do array crate and give it a size. And before you could do, for example, type, let's see, I32, so you could have integer arrays, and you could have byte arrays, and you could have unsigned arrays, and I think float arrays as well, but now it only supports byte arrays. And yeah, I don't remember if this was the syntax even. I think it was the syntax. For sure, if you just put the array in like this, then you could put the type in the beginning here, but that doesn't work now either. And the main reason that we did that, or two reasons. The first one is that you can actually express everything in byte arrays if you use the buff get and buff set functions. So you can just interpret them as different types in the array. And it also, the second reason is that it also removed a lot of code, so it means that LBM got lighter from it, and there is less code to test. That well, it's just a bit easier to maintain this way, and I didn't end up using anything other than byte arrays anyway, because generally you would use a list, and a byte array you use if you want to have it store it really compact, or if you want to send it somewhere, interact with C, and then a byte array is much more useful anyway. So that is everything I had for now. Some of those things are probably not fully stable and working at the moment. I think in the past days we found a lot of things, a lot of bugs in the flash memory implementation in the incremental readers that are quite tricky, and now when I make this video I think everything we have found is resolved. But if you find something else, then you can let me know, and then we will try to fix it so that it also works. So that's all I had for now.